Hey, it's DK again. On this video, we're just going to do a software simulation for turning on the LED, but using the wiringPi library. And we need to use the wiringPi library. Otherwise, we'll have to write all this minute programming code that we wouldn't have to otherwise do, if we had the wiringPi library. So wiringPi library allows you to manipulate that 40-pin connector with things going out, signals going out, signals coming in, and a few other things. That makes it a lot simpler. So we're going to use the wiringPi library. So let's go ahead and write a program that simulates turning on an LED and turning it off, all right? So actually, we'll just turn it on, and then we can actually alter the program to turn it off if we want to. Okay, so again, I'm running VNC from my Raspberry Pi to my iMac. All right, I'm running VNC right in here. All right, so again, I'm going to store all my programs in my progs folder. All right, see that right there. So I'm just going to go ahead and get rid of my a.out because really, I really don't need it. Okay. If I have another a.out, I'll just generate it and be done with it. All right. So, I might want to do some GVIM stuff, right? So I'm going to go up here to Applications, and I'm going to go to Accessories and start my GVIM. And there's my GVIM, all right? All right, so again, I'm going to, maybe I'll go ahead and save it first, right? Save a spot for it. It's always a good idea to save a spot for it, give it a name, all that kind of stuff before you start writing a program. So I'll just go ahead and do that. So I'll go to File, Save As, and I'm going to save it in me, or actually on a desktop, right? In my desktop, in Programs. And already I have my How's That One program that we just did. I'm going to put the LED on 1.c, okay? LED on 1.c. I'll go ahead and save that. And hey, look, it's telling me that my program name is LED on 1.c. Fantastic. So I'm going to start off always with, with insert. So I have to insert, right? Okay? And when I hit the I button, keyboard, it shows me an insert on the lower left. It gives me a little cursor that's blinking up there. So I'm going to do a double slash for comment. And ENGR 102 dash, I think this is section 3. I don't know. I'll find out if I'm wrong sometime. And then I'm going to write my name. This is DK. And then assignment LED on using software, okay? So a lot of times, okay, you want to do things in software because you want to make sure that your logic is working right, okay, when you do your program. So instead of actually running a program to actuate the 40-pin connector to light up an LED, you want to make sure that your thinking process and your writing process in your program is rational. So in order to do that, you need to maybe do a software simulation of it, okay? So instead of actually lighting off an LED, you print LED on, right? So in this case, my program name is LED on 1.c. All right, so again, we're going to have to do the #include stdio.h, which includes all the standard library functions. That allows you to print, that allows you to do data entry and that kind of stuff. Also, we're going to have to include this thing called wiringPi, which we will use extensively in this class. wiringPi.h, right? Okay, so wiringPi actually does not reside in your me directory or folder. It actually resides in root. And if you remember the class time, we spent a lot of time, and there was some angst and some bugaboos when we try to run things in root. So I have an alternate way of doing that. Well, running everything in me, okay, or on a desktop in me. All right, so that's that, and then we'll go ahead and start the. So wiringPi has all those instructions and functions to manipulate the pins, okay? That 40-pin connector. All right, so we're going to go ahead and start the main program. Int main. I think that read is this. All right. All right. Now the first thing you got to do is you're going to have to set up the pins. You have to tell the pins, the 40 pins connector, hey, you know, I'm going to use the wiringPi now. All right. Remember, this wiringPi.h, all that did was allow you to bring in the library of functions that you're going to use. But you're going to have to tell the the pins now, hey, I'm all set up for the wiringPi. So what you do is there's an instruction for that, special instruction, pi setup, and then open, close bracket, semicolon. Okay, remember the semicolon? Okay, if you miss a semicolon, it's a deadly semicolon error. You don't want that to happen. All right, so check it out. You know, in the wiringPi setup instruction right there, you see the P is capitalized and the S is capitalized. All right. Okay, so we set it up. All right. So I'm going to turn the LED on. Okay. So I'm going to say printf \n LED on. Okay. And \n, make it 2 spaces, you know, why not? Double quote, right parenthesis. Hey, look, you know, the thing with these parentheses is if you have a matching pair, it'll light up that way. Okay, if you miss parentheses, you know, it's real easy to find because matching pairs will light up, right? And semicolon. Okay. And if I exit the program now, it'll actually say LED on, okay? But I want to do something else, all right? So I'm going to put a little bit of a delay in this program in order to, before I turn the LED off, okay? So, so right now, okay, in the program, it's going to turn the LED on, okay? And it's going to actually display on the CRT, on the monitor, that LED is on. Now, in real life, there's going to be additional instructions in here where we use the wiringPi.h library to do some stuff, but okay. So I'm going to introduce a while statement, all right? So in order to do that, I need to declare a few things. So I'm going to go back up here. And I'm going to declare something, okay? So when you use variables, you have to declare them, okay? So any variables that you use, you're going to declare, right? So I'm going to declare that I'm going to use some variable called I, and that's an integer, okay? So integer variable called I, okay? And so that's a very common way to declare integer variables. So just go in here. Oops, I don't know what happened here. I think I just messed it up with the display. So I'll just go down here and back up. Maybe it'll bring it back up. No, I kind of messed up the display with VNC. But I know that's true. Okay, so what I'm going to do is just go ahead and keep typing. All right, so what I'm going to do now is start the iterative process. The first thing I do is set I is equal to 1. Okay, give it an initial value for I, and then I'm going to use this thing called the while statement. So while I is less than 50, let's say, okay, I'm going to allow this loop to go around, okay? So I'm going to say I'm not going to do anything. I'm just going to let it keep doing things 50 times. All right. So I'm going to say waiting. Okay. All right. Okay. So I'm waiting for this loop to finish 50 times. All right. It's not doing anything. I mean, you know, what I could do is I could print LED on 50 times. All right. But I'm going to choose not to do so at this point. Now it's going to do that. And then once it's done waiting for 50, once it's done doing this little loop for 50 times, actually what I need to do is increment the value. I is equal to I plus 1. Okay. There we go. I is equal to I plus 1. I'm incrementing for 50 times. And so what's going to happen is every time it goes through this loop, it's going to take the old value of I, which is the first time it's going to be 1. 1 plus 1 equals 2. It's going to say, is 2 less than 50? No. Then it's going to go through the loop again. 3 less than 50? No. 4 less than 50 until it gets to 50. 50 less than 50? I'm sorry. Is I less, if it starts at 1 and it goes through here, is 1 less than 50? Yes. It's going to go through it. It's going to increment it so that I becomes 2. Is 2 less than 50? Yes. As long as the answer is yes, it's going to keep going around this loop. As soon as the answer is no, that is when I is equal to 50, as soon as the answer is no, it's going to kick it out of this loop. Okay, it's no longer going to travel around this double bracket, two curly brackets. At that time, I'm just going to go ahead and print F backslash and LED off. Okay. Okay, and I'm going to end the program. So I'm just going to close the bracket. Okay. All right, so that program should be okay. So I'm just going to go ahead and file, save as, LED on. Okay, LED on 1, save. Fantastic. So I'm going to go ahead and get out of here. Exit. All right, so just for grins, I'm just going to go in my programs, and I see my LED on 1.c. I'm going to double click on that. It should be bringing up my gvim file. Just want to make sure that it entered everything right. Sure. #include stdio.h, #include wiringPi.h, int main, and then integer I. That's an integer variable called I. Do the wiringPi setup, and I printed LED on. I is equal to 1. While I is less than 50, I'm gonna do this loop. Sure, for the first time I is equal to 1. Fantastic, until it goes to I equals 50. Once I equals 50, it's no longer going to go through this loop. It's going to execute, it's going to skip through all of this stuff and go all the way down here to this print LED off, and then quit the program. Fantastic. So I'm just going to file, exit this, okay? So that looks good, all right? So I don't know what that is. That's just a leftover character from my VNC config. All right, so now I want to compile that. Okay, so here's the deal with the compiling, all right? Here's my terminal, all right? So remember I told you that the wiringPi library is in root, okay? But we don't want to go to root. So I'm just going to go ahead and find my my files. So CD home, right? It's in home. And then it's in me, CD me. And then it's on my desktop, CD desktop. All right. And then it's in progs, right? CD progs. And then, yeah, there it is. There's my LED on, okay? LED on 1.c. So here's how I'm going to compile it. Now I need to be able to access the wiringPi.h library, which happens to be in root, which is unfortunate. And the way we tried to do it in class was you did a super user to root, and tried to run everything in root. That seemed to have some issues, so I thought of another way, which is doing it this way, and I'm going to continue with this alternate way. So what you want to do is you want to do sudo, okay, which is like super user do, okay, super user do. You're going to be the super user, you know, the superhero, and then be able to access everything in root, okay, sudo, and then you're going to do the gcc, okay, and you're going to do led on 1.c, which is the program, and then you want to include the library -l. Okay, that includes the library for wiring wiringPi. Okay, you're going to include the library function wiringPi. This includes the wiringPi.h business. Okay, in the program, and I suppose we can do /-o. LED on, okay? So that'll give us an output file, executable file, LED on. Or you could just do it a.out, either way. So I'll just do the LED on, all right? No, the heck with it. We'll just do the a.out, okay? So notice I've got sudo business in there, right? So I do that. Hey, it executed. That's great. So I'm going to do an ls. There's my a.out, okay? But the a.out is still in me. It's not in root, okay? A.out here is corresponding to the very latest program compiler compilation, which is associated with LED on 1.c. So I can't just execute the program like I did. I can't just do this, okay? Because I need to be able to access the wiringPi library. Let's see what, well, maybe it'll work here. It might work, okay? If I do that, nope, it can't. Okay, it must be in root. And it tells me, hey, did I forget sudo? Well, yeah, I forgot sudo. Okay, I want to be a super user, you know, being able to access everything in root. So I'm going to do a sudo /a.out. LED on, LED off. Wow, 50 times. It didn't take much, did it? Right? Didn't take much. That's a bummer. Obviously, I have some syntax errors in there, so let's just see, because it shouldn't show me that \n. So I'm going to just move this over and double-click on LED on again, and kind of like change the program a bit, because obviously I have some errors of some sort here. I have a double slash. Okay, so I know that I goofed. So I'm going to hit the I button for edit. Okay. I don't know why it's not letting me edit this thing, but all right. Escape. Here we go. We'll just edit it like this. Well, not letting me do anything here for some reason. All right, so I'm just going to close this window and try this again by running gvim. All right, and I'm going to do a file, open, desktop, programs, LED on. Maybe it'll be happier that way. All right, I think it might be happier that way. Sure enough, okay, great. All right, so, well, maybe not. So I'm just going to go ahead and delete that line. Edit. Yeah, it's not happy here for some reason. There we go. So I can cut this whole line, I suppose. Cut this whole line out. Okay. Theoretically, it's not there. And do things with it. But anyways, I had a little program error. Yeah, save those changes. Let's see what those changes look like. Yeah, so there's the waiting. I'm going to go down here and I'm just going to tab, insert, tab, and I'm going to say printf \n LED off and \n. All right. And I'll go ahead and save that. File save. So that's what the program kind of looks like. Okay. File exit. And let's take a look at it again. LED on. Yep, the program is working. There's my printf, LED off, LED on. And I don't know where my close. Yep, there's a close bracket for the whole thing. Very good. All right, so it should actually compile. The style is not that great, but that's okay. All right, so let's see if I can compile this thing. Sudo gcc LED on 1.c and then -l wiring pi. Oh, I have some errors. All right. So, all right. So what are my errors? My errors happen to be no parenthesis there. All right. No, no colon. I mean, no quotation mark. All right, great. All right, so let's see. Let's make the wait longer than 50. Let's make it 500. Okay. While we're there. Okay, so I'm gonna take this, and I want to escape, write this thing, and then quit. Okay. All right, now I'll do GCC sudo GCC LED on -l wiring pi. And again, there's a mistake. I misspelled print. Okay. So I'll go ahead and take care of that print thing. I can see where I made that mistake. So I'll expand this out so I can make the correction. So I'm going to insert print. There we go. So that should do it finally. Okay. Escape, right, quit. Try this again. Hey, it compiled. Okay. And then I'll do a sudo a.out. Oh, sorry. Sudo /a.out. LED on, LED off. That's exactly what we want. Okay. And there was a slight delay there. You could see not much of a delay, 500. So you see, even if I did it 500 iterations, it really didn't make that much of a difference. If I want to increase that, I can go ahead and do that. I can say, I can go and do an application, increase the wait time. All right, so I'll go to gvim. And expand this out so I can see it better. And then I'll go to File, Open. Under Desktop, Programs, LED on. There it is. It's doing 500 times, so maybe that's just not enough. So I'm going to go ahead and insert. You see the insert thing at the very bottom here. Make it 5,000. Let's see if there's any kind of delay that we could discern, okay? Hit escape. Go ahead and write it, and then quit, okay? So I'm going to do a sudo gcc led on 1.c minus l wiring pi minus o, what do we call the output? Oh, we didn't actually call it output, okay? There we go. I compiled it okay, no errors. We'll do a sudo /a.out. Still can't discern it. You see, it's so fast that you can't see it. So I might actually have to do thousands of delays in order for me to see the difference between LED on and LED off. So let's do it one more time. Okay, I know time is precious for you, but let's just try it one more time. So I'm going to do applications, accessories, GVIM. All right, and I want to open desktop program progs LED1. All right, I'm going to insert. I'm going to go into insert mode. Notice the insert mode here. I just typed in I. Or actually, I think you can do it here, right? You can actually do an insert mode in here somewhere. Maybe. Maybe not. Okay. So, edit, paste, cut, find. No, it doesn't have an insert mode. Okay. So, I'm going to go back down. That was 5,000 iterations that I was doing here, right? So what happens if I do 50,000 iterations? Okay. I'm going to hit escape. Hit the escape key, colon, W. That'll write. That's written, and then I'll quit, okay? Now, I just use shortcut keys, but you could actually use the menus. All right, so in order to actually, I don't have to type in the sudo gcc. I can hit the up arrow, okay, on my keyboard. Well, I don't want that. I want to go up one more. There it is, all right? Sudo gcc led on 1.c minus l wiring pi. Compiled just fine. And I want to run sudo /a.out. It's still pretty fast, huh? All right, so you might actually have to put a very long wait in there in order for it to, in order for you to see a difference between LED on and LED off, right? Okay, so anyways, so this is your program. I know it's taken 28 minutes with some errors, but it's good that you saw that I made some grammatical, rather spelling errors and that kind of stuff, because it's, you know, if everything was perfect, right, then you wouldn't know how to get out of things if things were perfect. Things were not perfect in this video, so you saw how I actually didn't lose my cool, just kind of figured out what was wrong and then corrected everything as I went. All right, so thanks very much for hanging out with me, and I will see you in class.